Hello everyone, and welcome to this new and exciting session in which we are going to be looking at load testing. The load testing tool we'll be using will be Locust, and Locust will permit us not only define user behavior with Python code, but also swarm our system or our API which we've built already with millions of simultaneous users. So in this course, we'll see how to test, or better still, to load test the API we've built previously, both locally and on the cloud. Don't forget to subscribe and hit that notification button so you never miss amazing content like this. At this point, you've already tested the model which has been deployed on Oracle, and everything looks fine. But then, what if we tell you that we will have to still carry out some load testing? Now, what's the point of load testing? The point of load testing here is to see how this your API which you've built will react when you have many users. So you wouldn't generally want to create APIs to be used by yourself only, but maybe to be used by tens of thousands and even millions of different simultaneous users. So we cannot get access to this millions of people, so you wouldn't start calling each and every one of these people here to test your API. And what you do is to have an automated system where these millions of users are simulated, and this tool we'll be using here to simulate this millions of users is Locust, which is an open source load testing tool. So here, what we're gonna have is this locust.py file which we're gonna create, and then we'll go ahead and do pip install locust. Now we have our locust installed. We could go ahead and get back to our code here and create some different tasks. So Locust functions with tasks, and we'll start by creating this. We'll start by creating this our task. Let's just call it detection task. So detect detection, or let's say YOLO task. So let's call this YOLO task, and then this is a subclass of sequential task set. Let's get back here and import this. So we have import, or rather from Locust, we're gonna import the sequential task set. Okay, so we have that imported. So once we have this imported, now we'll get back into our task class, and then we would create a task. So here we have our task decorator. That's it. And then we have this method. Now this method is basically our detection method. So we're gonna try this, or we're gonna in this YOLO task class define this detection method, which will be called every time. And so when we want to simulate the millions of users, or the hundreds or thousands of users, it's gonna basically run this detection right here. So we have this detection method which we define, and then what we'll do now is dive into the actual testing. So we'll take a test file we have we'll open up this test file. Let's just call it test image. So we have this test image right here, and then we're gonna now pass this test image via a post request to our API which we've hosted online. So we have our test image, and then we do this post request. See, it's quite easy with Locust. So we have that, and then now remember that the way this API was built was such that we have the API, and then we should have detect. Now let's check here to be sure of that. So here is detect. You see, you have here /detect. So because of that, we'll get back here. You have API, you have /detect, and then we are gonna pass in our image. So this is a post request here which takes in the image in the body. So we have your files, and then we specify our image. So we have this as im, because that's basically how we define this in our code. So this here should be im. Now let's get back here, so you see that clearly. You see here, this is im. So if you change this, you should also change that the level of Locust. Let's get back here. We have this image, because we've opened this as image, so we have this image which is going to be passed. And then once we have this image now passed, basically we're going to be able to run this testing process. Now we've defined this task, YOLO task. We can now go ahead to carry out the actual testing, and now we'll make use of HTTP user for this. So we have HTTP user. There we go. We have this other class. Now we'll call this load tester, and then this is a subclass of HTTP user. Okay, so we have that, and now we're going to specify the host. So our host here is simply this one. So let's get here, copy this out, and then we paste this out here. There we go. We paste that out. Let's take this ones off. Okay, so that's it for our host. We remove that. That's it. We have our host there defined, and now we're gonna specify our tasks. So this means that we could specify other tasks, but since here we have this just this major task, we just have to specify this. So we have YOLO task there. Okay, so that's it. We'll specify the YOLO task. You know that you could do many other stuff, like you could decide that, because this is a sequential task here, meaning that after this it's going to run this, and so on and so forth. So you could decide that once one user tests, it keeps like say 1 second before another user gets to test. Now another import we need to make here is task. So we import task, save that. Then in the command prompt we have locust file, and then we specify the file locusts.py. Okay, so that's it. Now we should be able to start the web interface at this. You see here, this link, you click on that, and that opens up. So yeah, let's just click on the start swarming. We have that. Now let's get back to this, because you see we have an error, no such file found. Okay, so we have this file which we actually specify here, but which we don't have. So we're gonna copy a file into this same directory, so that we could be able to test this. Okay, so now we have our file copied. Let's rerun this and let's see what we get. Get into this. Start with number of users, swarming. Let's get back. Oh, okay, so you see it's working. So we get back here, and then we check this out. You see that we have from just this one user, you have simulated for the number of requests are actually increasing. So we have number of requests increasing. We have fails, so it's failing. The median time to get the response is 2000 milliseconds. The 90 percentile median time is 2500 milliseconds. 99 percentile millisecond is 2600. The average is 2231. It's actually updating. The minimum time we've gotten to receive our output or our response is 1600 milliseconds. That's 1.6 seconds actually. The maximum is 2.6 seconds. The average is information with transiting here or transferring is 506 bytes. The current requests per second is 0.4 requests per second. The current failures is 0.5 failures per second. Now here we see that for all the requests we're basically or practically failing. See, we just practically having only failures. Then when we click on this failures here, what we have is this server error, service unavailable at this location. So let's get exceptions, current ratio. So now because of this, we could go ahead and check out the logs. So we get here YOLO X nano neural learn. You go to view logs, and you should be able to have that. Now either you have this, or you get here, you see you have this logs, you get in the logs, which will be helpful in debugging. So when you have issues, you could get back here and debug, and then or you could have here, you get back to the code. Let's add another terminal. So let's have this one, and then let's do Heroku logs. So we have that. We should be able to view the same logs we viewed on the Heroku platform. Okay, so that's it. We get in this Heroku logs. We can also specify Heroku logs tail. So we just get we'll have a situation where we don't like previously we had Heroku logs and then it just showed this logs and then that was all. So if we want to keep getting the current logs, we just get to the tail. So we get the most recent logs, which is going to be shown to us. You see here, keeps showing us these logs. So it's important to know how to use tools like this, because when you have issues, you could be able to get an understanding of why your program isn't working. Now, funny enough, when we test this out here, so let's try this out. Let's pick a file, downloads. Let's have that. We execute. What do we get here? Let's see if we actually get in that same error. You see, it works. So this is actually working when we test this out here. Now let's cancel here and then check out this URL. You see that here we have detect, but in our code here we put API detect. So let's get back here and take this off. So let's save that again. Get back here, start with Locust, open this up. Let's close this other pages here, and now it should be fine. So let's start swarming and see what we get. You see, we no longer have failures anymore. Now we just have our requests and we have our outputs. And guess what? We have a much smaller latency. So we've left from about 2.6 to now around 0.4 milliseconds. So now it takes about 0.39 millisecond, 0.39 seconds to receive an output when we are working with one user, and we having no failures. See, it's now actually working. Let's increase that again. Okay, so from here we could look at the charts. You see the failures, the failures, and then here's the number of requests you can make per second. You see, it keeps increasing, dropping, increasing, and so on and so forth. So you could view this in real time. This means that now with one user you could be able to simulate like this and know exactly how it's going to function if you deploy this in real world scenario. Here we have the median response time, and then we have the 95% percentile response time. So here we have this, we could see that, and then we have the number of users is still 1. Now what we can do is we could reset the stats. You see, you could reset the stats from afresh again, and then we could from here we could stop this, and then we could do a new test. You see, it's that easy actually. All you need to do is stop and start a new test. Now let's suppose that we're having 10 users. Then the spawn rate right here defines the number of users we're going to start with. This means that if we take one, for example, you see, we take, for example, one user, we're going to start with one user, and slowly this number of users will get to 10. Now if we take say 5, we're going to start with 5, and then slowly that will get to 10. If we start with 10, then that will be it, since we already have defined the number of users to be 10. So let's start with say 2, and then let's start the swarming. You see that here we already have 10 users. It's taking a while because the server was off for some time, so it needs to start that. You see, number of users are going to increase from 0 to 10. Now we have that. See, number of requests per second, 2 requests per second with 10 users. Here we have 3.5 requests per second, and so on and so forth. Now let's look at the statistics. So the median time here, or let's look at the average time. The average time is 2 seconds. So you see that when we were dealing with one user, our average time was like 300 milliseconds. But now this goes to 2000 milliseconds because we have many more people using the API. One other thing we could notice is these values are changing, and we've had so far a minimum latency of 447 milliseconds with a maximum of 3.8 seconds. Then we've had no failure so far. Now when we get back to our Swagger UI, let's try this out. We load an image. There we go. Execute. Let's see what we get. See, it takes a while, and then we should get our response. See, here we told 0.03 seconds. That's 36 milliseconds. Now you see that getting that value or using only that result to test the speed of your API isn't a good idea, because as you've seen, you might have built this model right here, and then when information passes through this model here, when information gets through this model, you have a time of say 0.05 seconds. That's 50 milliseconds. So you have 0.05 seconds to receive the output. But the difference is that now when you package this model in an API, you see, when you have this API you've built with FastAPI and all of that, you are not having only one request as you may find here. So that's why let's get back here. That's why when you make this, you run execute, you see here we have 0.036 seconds. That's 36 milliseconds. But then this doesn't reflect exactly what's going on, because let's get back here, because in the real life you may have many people trying to get access to this. So you see, many people are trying to get access to this. Now even if there were just one person trying to get access to this, this person has to send this request. That request has to get to the servers, and then person gets to the model, produces an output, and then the user has to receive this information. So what you get with Locust isn't just this latency for when you pass information into the model and get the output, as what you get now is what any user located anywhere in the world would get if there were a certain number of users using the API at a given time. So let's suppose that we have 10 users as we've simulated. Suppose now we have 10 users at a given time. If this user tries to get access or makes use of that API at that given time, at that instance, when 10 others are making use of that same API, then the time for that user to receive the output or to get the response is going to be 2 seconds and not 0.05 seconds. And obviously when you're building a real world system, you would want to consider this instead, as this is what your final user really cares about. Nobody wants to get into knowing maybe this, because what they want is, I pass information, in how much time do I receive this output? Now if this 2 seconds is too much for the users, then you would have to increase the server's capacity. Now let's get back here, check out on Locust. You see we're still doing good here. We have an average latency of about 1.8 seconds. Now remember that with just one user, the latency was about 340 or let's say 0.34 seconds. Now we would have expected that maybe if this was linear, then at 10 users we should have a latency of 3.4 seconds, but that's not the case, as with 10 users we have a latency of instead 1.8 seconds, which is rather great. Now we could keep playing around with this. Let's say we want to have 100 users, spawn rate of 2. Start that. See, increases slowly up to 100. You see that now the latency is going to be obviously greater than what we have had so far. See, at 34 users we're about 3.2 seconds. But if there's one thing you should note now, is that we're getting some failures, which is not a good thing, because we don't expect to have this kinds of failures when we build in a real world API. So we have to make sure that we avoid this kinds of failures by increasing our server capacity. because clearly these failures are coming from the fact that we have maybe too many users. So here you could see 100 users, failure, see, is increasing. The average, see this average here, too many failures. Now let's stop that. You see that? Let's stop that. Get back to, say, let's say we just have 5 users per second, and that's it. We could get back to our charts. You see we have 5 users. We could see here total requests per second, and then we have the failures right here. We could scroll here and we have the median response time. We see it increased once we increase number of users, and starts dropping when the number of users was 5. So that's it. We have number of users. We left from just about here we're at 10 users, we went to 100, and now we down to about 5 users. Now the failures too have greatly dropped. Hopefully they should drop to 0%. So that's it. Next thing we'll do is we're going to do load testing for our API, which has been deployed locally. So here we already have this, you see, localhost, and then let's copy, let's say we copy this, then get back here, we stop this, do a new test. Let's specify this host here, we start, and then see what we get. Okay, here we have 5. Now let's edit this, let's edit that, number of users 1, that, and start. Okay, so that's a host there. We have this number of users, 1 user. Now what you notice is this increases greatly now. Now let's get back to the statistics. What do we see here? We have this average of 11 milliseconds. You see, with 1 user you have 10 milliseconds. That's great results. But one thing we didn't notice here was the fact that everything is failing. So let's get back to the code and see why that's happening. So here we have this not found. We stop that, then we get back here and we change this host. So let's have this, we save. What do we have here? We run this, that's fine. We get back to Locust. Let's have this again. That should be fine now. Click right here, and there we go. Okay, so we have our host and then number of users. So let's start again and see what we get. 1 user, there we go. You see 0 failures. Now if we look at our average, it's 37, which is kind of similar to what we've had already here when we were having this. If we get to docs, let's check out the docs, try to detect, and then you see, you try out, take this image, whatever image we have here, execute that, and then you see this 0.05, that's 53 milliseconds. If you run that again, see 36 milliseconds, which coincides exactly with what we have already here. See, about 40 milliseconds. Now let's stop this and then let's do a new test. You see that now we have, for every user we could make, let's start back at 1. We just want to check this number of requests a user can make per second. We see that here 1 user, let's get to the charts, see it's increasing. 1 user gets up to 22 requests, 24 requests per second. That's great. And then with this here we have 41. Okay, so we've seen that. Just wanted to check the number of requests per seconds. Let's get back to this. Let's say we want to have 100. So let's get to 100 users accessing this locally. Now we start, then see, keeps increasing. There we go. We have 30 requests per second for 100 users, and every user gets an average of 2 seconds to receive their responses. And that's it for this section on load testing.